This is question number 11 of Code E of Physics Main JEE 2016. A uniform string of length 20 meter is suspended from a rigid support. A short wave pulse is introduced at its lowest end. It starts moving up the string. The time taken to reach the support is. Before I describe you the question, let's go over a little bit of theory. What is a transverse wave? It's a wave in which medium vibrates at right angle to direction of propagation of wave. What do I mean? Let's say this is a string as given in the question and it is 20 meters long, and if I hold this point and give it a shake, the string will vibrate something like this, right? So this is actually half of the wavelength, and so the string will vibrate in this direction while the propagation of the wave is in this direction. So vibration is perpendicular to the direction of the propagation of wave, and if this is the case, it's called a transverse wave. Next, we'll see what tension is. Tension is just a force. We know that force is equal to mass into acceleration, and then tension is force on a rope or a string or a chain. So when we are talking of a rope or a string or a chain, then the force with which this string experiences, let's say there's a weight here. In this question there is no weight, but let's say there's a weight here, then the force that this rope would experience is called tension. Even if there is no weight attached to a string, if the string itself has some weight, then it will experience some tension. For example, at this point the tension will be maximum. I'll cover it in the video. So that's what tension is. Now let's see what the question is. A uniform string of length 20 meter is suspended from a rigid support. So this is the rigid support. A short wave pulse is introduced at its lowest end. This is the lowest end, and this is where a short wave pulse will be introduced. It starts moving up the string. The time taken to reach the support is. Alright, so in how much time will the wave which starts from here reach here? That's the question. Let's see what the formula for tension is mass. It's not mass, it's mu into gravity into x, or small m into gravity, acceleration due to gravity, multiplied by x, which is the distance. So what is m or mu? Mu or m is the same thing. It is mass per unit length. So in this question, let's say the string has mass m, so mu will be mass per unit length. And why do we need mass per unit length? Well, because the tension experienced by the string at every point is different. Mass per unit length multiplied by this small x, which is this distance, is what will determine the tension. So for example, at this point will experience or will be pulled by this weight of the string, right? Similarly, at this point the molecules of the string, or the part of this, a small part of the string, will be pulled down by this weight of the string. So that is why we need to account for this x, because this x will vary when the pulse moves forward. The x varies, and the tension experienced by the string at that point is different from the other points. So this formula really T gives the tension experienced by a part of the string at a particular point determined by x, which is the distance from the initial point or the lowest end, this point. Alright, so that's why we can write T is equal to m, where m is the mass of the string over length, which is the length of the string, multiplied by acceleration due to gravity, multiplied by the displacement. Alright, and let's see what is the formula for v. Velocity is given by the formula square root of tension over mu. Now, so this means that tension is directly proportional to velocity. Why would this be? This is because the greater the tension on the string, the less it will tend to vibrate in this direction, right? The string will be pulled down if there's greater tension, and less will be its tendency to move here. And that means that if the pulse is not moving to a very large distance, it would move, and if it moves only to a small distance, it would move that much faster to this point. I think that is intuitive, but really that's how it is, right? So if it does not goes to a far, the disturbance will move very quickly to here. The wave takes the path of least resistance, right? And then if there's too much resistance, too much tension, and there's too much resistance going to this part, then the wave will move quicker along this path. So I hope that is clear. And then it is also inversely proportional to mu, which is mass per length. So that is the formula for velocity. If you want me to derive this expression, comment below and I will derive. However, for JEE, it's not really a part of your syllabus in NCERT, but if you want me to get better understanding, let me know in the comment section. And also let me know if you want me to derive this T is equal to mgx, right? So what is then V is equal to tension? I will, instead of tension, I will substitute this formula, this expression, and I'll get m by L gx. Mu by definition is mass per unit length, so these two m by L and m by L will cancel out, and I'll get square root of gx, right? So again, this is the velocity at a particular point, just as I explained that tension is the force experienced by a string at a particular point. This velocity is also the velocity at a particular point, and it is the point is determined by this value of x. And then if velocity is equal to square root of gx, by definition velocity is dx by dt, right? So displacement, where x is displacement, t is time, so dx by dt is equal to square root of g multiplied by square root of x. Now this gives me some idea that if I integrate it, then I will get the time, because I already have dt. So I can get the time, which is what they have asked. They given 4 options. So there is some intuition already that you could get time by integrating. So to integrate, let us first get all the like expressions to the one side, as we do in mathematics. So dx upon root x, right? So this root x, let me divide both sides by root x. So dx by root x is what I'll get, is equal to square root of g times dt. Now what is root of x? I can also write root of x as x to the power 1 by 2, or if I take it to the numerator, I can write x to the power minus 1 by 2 dx. And then how much do I want to integrate it? I want to integrate it from 0 length, right, to the full length. So I want to integrate it from the pulse starts from here and ends here, so I want to integrate it over the entire length of the string. So I'm gonna write 0 to L, and then on the other side also I want to integrate, so that will be square root of g. Now I know g is constant, so square root of g is also constant, so it can come out of the integral part. The constant cannot really be integrated, so I'm left with dt. So integral of dt is t, I know, and that's what I'm looking for. And then from where to where should I integrate it? So I am gonna integrate it from 0, the initial time when the pulse starts, to the final time when it ends, 0 to t. That will give me the time I need. So what is integral of x to the power minus 1 by 2, right? It's just, if you use this formula, x to the power n plus 1 over n plus 1, right, dx. So that will give you the required result. So x to the power minus 1 by 2 plus 1 by 2 is x to the power half, over minus 1 by 2 plus 1 is half. I'm sorry, x to the power minus 1 by 2 plus 1 is plus half, that comes here, over minus 1 by 2 plus 1 is plus half, that comes here, is equal to square root of g to t. Now this t is, I can also write it this way, 0 to t, then substitute it, to get the next expression, and this one is from 0 to L, right? So I can substitute, instead of x is the variable, I can substitute L to get L to the power 1 by 2 over minus half minus x. If I substitute 0, it's 0, so I'm not gonna bother about it. So I get L to the power half over half is equal to square root of g, and then instead of t I can substitute t minus 0, this 0, I'll get t minus 0 as t, so I'm not gonna bother writing minus 0. So this is what I get. Now to solve further, if I solve for t, I'll keep the t here and divide it by root g, and both the sides I'll get t is equal to 2 root 20, and then square root of g, they have said in the question that take it as 10 meters per second square, so I'm gonna write 10. So what I get is 2 square root of 20 over root 10. So since they are both square root, I can divide, no problem, or I can write all of it under root, and then if I divide, I get 2. So the answer would be 2 times root 2. And where did this 2 come from? From here, this 2, right? So this is the answer, 2 root 2. I hope you like the solution. If you like the solution, please subscribe to my channel, like and comment below, and share it with your friends. Thank you for watching the video.